Hello, today I'll be speaking about Lab 4, which is on bar magnets. The purposes of this lab are to measure the distance dependence of the magnetic field of a small bar magnet and to compare measurements to predicted results. The first fundamental principle is the Biot-Savart law, which gives the magnetic field of a moving point charge and involves the cross product of the point charge's velocity and the unit vector of its displacement vector, so the vector between the point charge and the observation location. This is a formula for the magnetic field of a dipole, which is important because we'll be dealing with a dipole in the lab, and mu here is the magnetic moment. The distance dependence formula is also important for the data analysis that will be done in this experiment. So basically, it just gives that the magnitude of the magnetic field due to a bar magnet decreases with distance, and the formula can be rewritten as shown on this slide. Just to give an overview of the lab, basically it involved the measuring of the magnetic field of a bar magnet with a phone, which you can see a picture of on the left, where the system is the bar magnet and the surroundings are the magnetometer, the earth, and everything else. So this was done at a variety of locations. So the magnetic field was measured at a variety of locations. And next, the second step of this lab was modeling this with WebVPython. And in the end, the magnetic moment of the bar magnet was found to be 11.05, and there was some variance in the predicted and the measured magnitude of the bar magnet, which we'll be getting in later. Just to give a brief overview of the experiment, first, the phone was set up in a way such that the magnetic field due to the Earth would not affect measurements. Then it was determined where the magnetometer is in the phone, and then the magnetic field was measured both on axis and off axis, as you can see at the bottom. So this is the data analysis, which shows kind of the line that was found as a result of these measurements on a natural log of the magnetic field versus the natural log of the distance graph. Here I did some calculations using the formula discussed previously to find n, which is given here. And these calculations also led to the conclusion that the magnetic moment is 11.05. So again, these are the formulas that were discussed previously. And then this is the data that was found for off-axis measurements, which includes an average for the perpendicular distance, and very importantly, of course, also the magnitude of the magnetic field at this 45-degree angle in the picture that was shown previously. So just to answer the given question about observations, the correct statements are number 1 and number 4. So when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the x component of the magnetic field increases. So these two are correct. The others are false. Now, getting into the model, the assumptions of this model is that there's no effect by the magnetic field due to the Earth, and that the bar magnet acts as a dipole, as a magnetic dipole. So here we're just setting up constants, creating the magnet, and then a function for the magnetic field with the formula that I touched on earlier. So here, basically, I took a measurement from my experiment, plugged it in here, and then using the function that I just mentioned, calculated the magnitude of the magnetic field at 45 degrees. And here is kind of the output of the code. So I used arrows to kind of show how or what direction and magnitude the magnetic field has around the bar magnet. And to get to the important stuff, this is what the model outputted for the magnitude of the magnetic field at 45 degrees. So to compare this to the measured value, which is 6.29 times 10 to the negative 5, it is clear that there's quite some discrepancy between these values. And it can be explained by the errors I'll touch on in a second, which affect the calculations done with this formula. So the potential sources of error is that the sensor in the phone was affected by other magnetic objects, such as laptops and surroundings. It might have been influenced by Earth's magnetic field, and of course, rounding in the data analysis. To answer some further questions, if the magnetic field due to the Earth hadn't been accounted for, um, the X component of the magnetic field would be affected because it's taking into account both the bar magnet and the Earth, not just the bar magnet. And if two identical magnets were stuck end to end instead of just using one, the direction of the magnetic field would not change, but its magnitude would increase at the locations. Thank you.